Assalamu alaikum everybody. I am Saiful Islam. My ID is 12208021. Today I will be presenting quicksort algorithm. Quicksort is a very important sorting algorithm. It is very well known for its efficiency and especially for a bigger data set. Quicksort is based on divide and conquer strategy. It divides the list in various subsections and sort them. First, it chooses a pivot and places the pivot on its final position. The smaller values left positioned in the left and the bigger values positioned in the right of the pivot. Then the left section and the right section are sorted in similar way. Each time it divides the list and sort them. For this reason, quicksort is a good example of divide and conquer. Here the basic steps of quicksort algorithm. It works by in recursive way. It divide the array in sections and sort them. Here you can see in step 19 and 21 the recursive call occurred. To understand the algorithm more, here we have a simulation of quicksort. Let's take an array. First of all, we have to choose a pivot. We will compare the pivot with upper bound and lower bound, and we will place the pivot in its position, and the smaller values will be in its left and bigger values will be pivot's right. Here are two conditions. If the array element of the upper bound is greater than or equal pivot, will decrement upper bound. Otherwise, we will swap the upper bound with pivot. And second condition is if the element of lower bound is less than pivot, we will increment the lower bound. Otherwise, we will swap the lower bound value with the pivot value. Let's see. Let's start from upper bound. Here you can see our pivot is 4 and our upper bound value is 5. We'll compare with two together. We can see upper bound is greater than pivot, so we will decrement our upper bound by 1. Again we will compare upper bound value and the pivot value. We can see the upper bound value is less than the pivot value, so we will swap the pivot value with upper bound value. Now we will move to the lower bound. Lower bound value is less than pivot, so we will increment lower bound by 1. Lower bound value is greater than pivot, so we will swap the lower bound with pivot. Now we will move to upper bound. Upper bound value is greater than pivot, so we will decrement upper bound by 1. Upper bound value is greater than pivot, so we will decrement again. Now upper bound value is less than pivot, so we will swap the two numbers. Now move to lower bound. We will increment the lower bound because the element of lower bound is less than pivot. Again we will increment lower bound. Now we can see lower bound and upper bound pointing one element. Lower bound is equal to upper bound. Here we will stop the loop and the position of pivot is now the final position of the pivot, and the smaller values are in the left and the bigger values are in the right. Now we will divide the array in subsections and sort them in similar way. We will choose a pivot here again, and the same conditions will be applied, and similar way the array will be sorted. Here is the second section. You can see our array is sorted. Here is a C++ implementation of quicksort. We will run the code in VS Code. Here is the input. Number of elements is 7 and the elements are here. We will now run the code. You can see that the output is here. The sorted elements are 1, 2, 3, 4, 5, 6. Now move to the presentation again. The time complexity of quicksort. The base case time complexity of quicksort is n log of n log n, because each time it divide the array in two parts. If the partitions are even balanced, then the best case complexity time occurs, and it is O of n log n. When the partitions are not balanced, highly unbalanced partitions will occur worst case, and worst case complexity is O of n square, and the average case complexity of time of quicksort is O of n log n. The space complexity of quicksort, the base case space complexity of quicksort is O of log n. The average case is O of log n, and the worst case is O of n, because the algorithm uses a recursive approach to sort the element. The advantages of quicksort. Quicksort is generally faster than other simple algorithms, making it well suited for large dataset. Quicksort doesn't require much additional memory because it sorts the array in place. Quicksort has an average time complexity of O of n log n, which is efficient for most input sizes. And quicksort is widely used in various sectors. Disadvantages of quicksort. The worst case complexity of quicksort is O of n square. It is not suitable for big data set, sensitive to pivot choice. Its performance depends on the choice of pivot. Poor pivot choice can lead an inefficiency. Quicksort uses recursive calls. If it doesn't handle optimally, it will occur an stack overflow because it is run in recursive calls. Here's the end of our presentation. Thank you for listening. I will hope this clarified the quicksort algorithm and its process to you all. Thank you.